Welcome to the latest edition of CSM Explained. My name is Timo Eich. I am Business Development Manager at CSM, and today almost everything revolves around when something revolves, namely what happens when we have to measure on rotating test objects such as axles, for example. Static and rotating components on the chassis must be subjected to load tests during the development phase to see whether they can withstand the stresses of reality. The most important measured variables here are, on the one hand, strains, meaning some kind of deformations, and on the other hand, temperatures, which exert an additional influence on the behavior of components and their materials. And in today's episode of CSM Explained, we'll take a look at how thermal and mechanical parameters can be measured reliably and as accurately as possible, and what the special features and additional challenges are for electrified mobility. If, for example, we take measurements on a tie rod and an axle control arm, then the mechanical load on the respective components should be important test variables. And in addition, the spring travel should then be determined as a secondary variable, as well as further information such as the vehicle speed being read out from a bus system of the vehicle. For the static components, strain gauge are a good option for measuring strains, for example, which can then be measured with a corresponding bridge measurement module. In this case here, an SDG6 Pro BS20 from CSM. And the spring travel, if we measure the spring travel, we would take a potentiometric displacement transducer, which is connected to a measurement module that is ideally suited for that purpose, such as the 84 IG1000 from CSM. And for reading the speed, for example, the body CAN bus, a VN interface could be there from our partner Vector Informatic. So we have already covered this topic in detail in another episode of CSM Explained entitled Durability Measurements in E-Mobility. Please feel free to take a look at our CSM Explained archive on our website. However, the question is, what do we do when we want to measure a rotating component, such as the drive shaft? Because with cable-connected sensors, such a measurement is only a brief pleasure, as you can well imagine. And for such measurements, we naturally need robust telemetry measurement systems that are suitable for road tests. And that is precisely why we have invited one of our partners today who are absolute specialists in the field of telemetry. It's AXON Systems GmbH and its Managing Director and Technical Director, Gerhard Spitz. Hello, Gerhard. Nice to have you with us.
Good morning, Timo. Thanks for having me.
Yeah, you're welcome. Well, dear viewers, today we are going to try something completely new, something that we have never been done before on CSM Explained. Today's episode will be in the form of an interview. That means I am going to ask Gerhard a few questions that I hope you will be interested in watching on your screens, and I'm sure we'll get some very exciting answers. And in the meantime, think about what you would like to ask and then simply write to us in the chat. And at the end, we will take up your questions if we have time and space. Does that sound good? I think so. So let's get started. Gerhard, perhaps to start with something very simple. How did you get into telemetry, and why does AXON assist? What is your mission?
Well, we're coming out of a team of engineers and technicians from a former measurement company, and like 20 years ago already, we had that vision to bring telemetry systems into a new level of, if we speak about reliability or flexibility. Mm-hmm. And that's what we did when we founded AXON in 2005.
Okay, really cool. So from your point of view, which measured variables must be recorded in rotation and why?
So there are, of course, many physical values which are interesting to measure on rotating parts. But if we have a closer look, many of those applications are to be measured in strain, like, for example, force or torque, especially. So if you have, on the one hand, the measurements of strain, then you have already covered a lot of tasks in automotive measurement projects. And on the other hand, of course, if you have some rotating machinery like gearbox parts, like drivetrain parts, everything, then temperature is a very interesting part to see. So these are mainly the two values which are to be considered. It's strain and it's temperature.
Okay, so and from your point of view, what are the challenges of measuring on rotating components, and how does AXON solve these problems?
Well, if you imagine a car, or automotive car, if you see a drivetrain underneath the car, so it's always very rough. So you have not perfect sterile laboratory, but you have really rough environments. So you have temperature, you have dust, you have dirt, you have water, you have oil. So this is one of the big challenges of a telemetry system, because you always have to measure really very sensitive signals. And on the other hand, if you imagine like a modern drivetrain or a modern car, there's not very much of space. So you need to be very flexible. You need to be very small and tiny, and to combine with, on the one hand, the robustness and the rough for the rough environments. On the other hand, the space situation, and these are one of the big challenges for a telemetry system. And then, of course, under these circumstances, you need to measure precisely and very reliable. These are the main challenges.
Okay, and I think AXON wouldn't be that successful if you did not invent something very special, how your telemetry system is designed. And I think we see it here on the next page. Maybe you can say a few words. How does this principle work?
Yeah, so when we started with the telemetry, we tried to really start from the sketch. So if you assume you have a rotating drive shaft on which you would like to measure torque, then if you ask yourself, what do we need? So on the one hand, of course, we need a sensor. That sensor is nothing we provide, so it must be a standard sensor, like a strain gauge in that case. You see it on this yellow schematic sketch. That's a strain, yes, that's a strain gauge. So on a usual measurement system, you go from the strain gauge right into your measurement system by cable. It's not possible here, of course, because we are rotating. That's why we try to develop a really small transmitter. You would need a small part which is connected to the sensor on the one hand, and on the other hand, it's connected just to an antenna. And the setup must be simple, must be small, simple, and reliable. And with this antenna, you must be able to not only to send the data, you always need to be able to receive inductive power, because on the shaft you can use any battery or something, because it's too bulky. It says open contacts. You need to charge or swap it. It doesn't work. So we need to supply this inductively.
Okay, and that, I think it came true, because we see now this picture here, which looks quite similar, just in reality now.
Exactly. So this is really a powerful and small measurement device, which is easy to install and covers a wide range of applications. And both the data and the power supply is wirelessly over a large range with this antenna setup.
Okay, perfect. So I think this is the part which is rotating. I think we do not see quite at the moment a few other parts. So what components does an AXON telemetry system consists of?
So we have now seen the rotor unit, the first part on the shaft, which is the tiny little transmitter, which contains a lot of technology inside already. But a standard telemetry system for this purpose is consisting of three components mainly. So we have the rotor unit on the rotating shaft, and if we have a rotor unit, then we need to have a stator unit, of course. Exactly, that's what we see there. It's installed right next to the shaft, and this does also both. It supplies the inductive energy and it receives the RF data. It must be very flexible, of course, and then it's connected by a cable to the control unit, which is, as the name says, the central control unit of the system. And this manages everything and plays back the data, and you can see you have a live data of the signals on your rotating shaft.
Okay, sounds really great. So I think this is a bigger picture here of, again, the rotor unit in combination with the stator unit. Let's say the stator antenna. We will talk about the antenna later on a little bit more. maybe let's stay with the rotor unit for the moment. So what are the most important requirements from your point of view if it comes to the rotor unit?
Yeah, this tiny rotating setup needs to allow a measurement tasks for wide range. So you need to have a flexible electronic, which is small and must be capable for many different measurement ranges. For example, it must be very rough and robust. We had a small issue that we need to really have a space-saving unit. And if you imagine a car, you can also imagine that it's getting quite hot sometimes. So we have temperature issues. So it needs to be worked until high temperatures. So for this example, we work on a constant load of 140 degrees with systems like this. And in this situations, they still need to provide really precise measurements.
Okay, so the data then has to be transmitted somehow. So how does the data transmission is working?
So on the rotor unit, we have an RF data transmission. We measure the analog signal in that case, from the strain gauge, and right after the signal conditioning, we already getting digital. So everything is calculated by a small CPU unit on the rotor unit, and it's transmitted digitally, which makes it even more safe and reliable in data transmission.
Okay, and yeah, here I think we see there's not only transmitted the sensor data, but a lot of different additional values over the transmitter, over the RF, as the transmitter ID and what's going on with this.
Exactly. So not only the essential measurement information is provided, the constant transmission of various operating parameters allows the telemetry system to self-monitor fully automatically. So it can adapt to the situation, especially on power supply. So if the generating system, knows how much power does arrive on the shaft, it can control it. It can power up or power down, and always have an eye on the inductive power supply to make really sure that we have no interrupts, that we have a really safe data transmission.
Okay, that sounds really smart, to be honest. So now I could imagine that a weight that I apply on the shaft creates some kind of imbalance maybe. So when I change my tires, they always say, oh, you need new counterweights on your tires. So is it the same with the telemetry, and how do you solve the issue with the rotor unit?
Well, it depends. So if we now see a drive shaft, a standard drive shaft, which is one of the most common applications, and like a drive shaft with a diameter of 3 to 4 centimeters maybe at the highest, and a speed of 3000 RPM is not really hard for imbalance. So you just can install the system with a flexible rotor unit, that will be fine. If we have higher speed shafts, you just can put a counterweight on the shaft, which can be provided, which is quite easy. Then you should be fine. And then, of course, it depends. If you have really high spinning shafts, like an exit of an electric engine, you speak about 20,000 or more RPMs.
Yeah.
You are able to fine balance your installation, and then you'll be fine.
Okay, sounds good. So are there any cases where we could not use this really great flexible electronic? Do you have other rotor units in your program?
Of course, it depends. So the flexible rotor units are very common because of the given nature that it really doesn't use very much space. But for example, if you see this picture, there are rotor units in an aluminum housing, so they are a little bit easier to grab and to swap between different shafts. They're more robust. And then this is just an example. Then we have other rotor units, like a small cylindric one, which can be put inside of a shaft, or a disc-shaped rotor unit, which is in axial size, very small. So for almost any installation, we have the right design. And as we have our own design team in-house, we even can adapt to very special projects with an individual rotor unit.
Okay, perfect. So I think we move on to the stator unit. So this is this lovely part here with this antenna. So what are the most important requirements from your point of view for the stator unit?
Yeah, so the main task of a stator unit is supplying the inductive energy and receiving the data from the shaft. And this is like the shaft, also like in the hot zone of the installation. So it needs to be very, very robust as well, and it needs to be flexible for the user. So if you imagine like a drivetrain or a gearbox or something, it's very difficult to install something like a telemetry system there. And then it's really helpful for the user to have some features which makes it really, really flexible. And also this one needs to be a high operating temperature. And also these are working far over than 140 degrees. So they're really, really temperature stable. And then if you imagine like a car on a drive shaft, the large transmission distances, which means you not always have a very central spinning shaft. It's always, most of the time, the drive shafts are moving a lot in radial and axial direction. And this needs to be covered by the stator unit.
Okay, so I think here with the stator unit with the antenna is this here. So we'll talk about the antenna in a moment because it's very important and a really great thing at your system. What's about the antenna? So maybe to round things up, what is the last part is the control unit. What is to say about the control unit from your point of view?
So the central control unit manages everything. It monitors the operating temperature or operating parameters of the systems and outputs the measurement data. And this box has always an eye on both on the efficiency of the inductive power supply and the efficiency of the receiving signal. So it's always auto-tuning and always trying to get the best out of the situation and regulates the system to its optimum.
Okay. And here, if we take a closer look at the control unit, we built a lot of plugs here on the back side. So maybe you can say a few words about all the connections here.
Yeah, it's not that bad. It's not so difficult. So we have you just power it by a supply voltage, and then you have your power on switch. On the left hand, the green connector is just the connector to. On the right hand, this is the power supply connector, and on the left hand, the dark green connector is yes, it's green-brown. This is the connector to the stator unit. So this is where the data comes from. And all the other connectors are like output. The systems always come with an analog output. So this is easy for any other measurement setups. It's easy to integrate. You have a plus minus 10 volt output. And on the other hand, you have a direct CAN bus output, which makes it also easy to integrate in a CAN bus setup.
Yeah, one remark from my side. So I have been in sales for over 15 years, and a lot of times people ask for this analog output, and I find it really cool that AXON still delivers systems with analog output. But I think it's very useful for a lot of purposes.
Exactly. Just imagine you have a big measurement chain with a lot of hundreds of measuring points on your CAN bus and a lot of systems between. And finally, on your monitor, you miss a signal, and then it's very difficult to see where it is coming from. And then it's always really, really helpful, and it will remain a promise in the systems, also in the future systems, that you have the possibility to just use a multimeter or oscilloscope and look at the original data at the system. So this is really, really helpful and makes it just easy to use.
Yeah, it sounds very practical for the practic guys out there. So do you have different versions of the control unit to offer, or is it one unit for all?
We do have different versions, but we really try to keep it as simple as possible. And you can see it on this slide that we have mainly two telemetry systems. We have one telemetry line for strain gauge measurements, which is the J1 dB on the left side, and we have one main line for temperature systems, which is the JXTH telemetry system. And these are the two main control units which are able to cover almost all installations.
Okay, perfect. So now we see here some challenges, of course. What are the biggest challenges if you're installing a telemetry system? So maybe from your point of view, a few words to that with the installation challenges.
If you're going to install a torque measurement shaft, for example, maybe the main challenge is installing the strain gauge. but because if you are able to install the strain gauge and handle this, you will be able to install the telemetry and to make this working. But of course, if you have to consider the installation space on your application, and then you have to think about how to protect it. Of course, there's a sensor, there's tiny virus, there's electronic. It needs to be protected against the environmental influences like stone chips, like water, like oil and everything. And of course, the centrifugal forces. So it should be on the same, the telemetry should remain at the same spot where you install it after the test. So it's very important to have this quite good fastened on your shaft.
Okay, and I think one of the challenges too is, as we see in this picture here, that the shaft may be moving very to a big degree with a possible deflection there in the antenna region. So I think this is also something that is quite a good thing at AXON, that it system allows to the axle to move a lot of distance between in this antenna region.
Exactly. So if you imagine your measurement task is measuring torque on a drive shaft, which is maybe even installed in an off-road car, and we did this a lot of times, of course, on also off-road racing and rally cars, and there you can imagine that like an axle shaft is moving really a lot. So you have the suspension and it's moving in radial direction up and down, and due to steering, and you have movements in axial direction. So all these movements needs to be covered by the telemetry system, and the system is capable to do this. And like you see it here in the schematic, it can be maybe like an oval shape of a transmission coil, and within this coil everything is supplied, and the system is working really smooth and without any interruptions.
Okay, would you say that this is a USP of AXON compared to other telemetry companies?
I would say this is state of the art. This is one of the most powerful systems you even can get on the market.
Okay, really cool. Okay, and now we had a lot of theory. Now it's getting really exciting for our practitioners, because we have prepared a whole series of photos now from actual installation situations at your customers at AXON. Well, we click through them, and maybe you can just say a few words of to each of them. So what do we see here, Gerhard?
This is a standard drive shaft installation on a car. And you see the yellow ring on the shaft is just a marker of the rotating antenna, that if you install the telemetry, you need to know where it is. And the white ring is the stator ring around. This is the stator transmission coil, which is upside down connected to the stator unit, the silver plug upside there, exactly. And this is how this customer solved the task. He just used like a battery cable. So you can use any cable with a flexible multiflex wire. You can make a solid copper band in any shape and almost any size, and the system will be supplied. And this is how this customer solved this task. On the left side, you see it a little bit more in a round size. On the right side, you see it a little bit more in an oval shape, just connected with a zip tie somewhere, and that's it. So this shows the flexibility of the system and how easy it is used to getting started.
Yeah, really cool. So here things are a little bit different. I think we have cable extensions here now, all right?
Same here. So a very flexible installation, and this shows pretty well that you don't have the transmission coil exactly mounted on top of the stator unit. There's a possibility to have some cable between. And this makes it also even more flexible. Maybe if the different parts in the cars are moving relatively to each other, this would be possible, make it possible to have the stator unit moving a little bit and the stator transmission coil moving a little bit, just flexibly connected together.
Okay, so for our audience here in the left picture, this orange cable here is the antenna. and we have here the stator unit, I think. And on the right, it's with extension cables, right? We have here, I think this here is the stator unit, and then we have the brown here is cable extension, and the actual antenna is here black with this coating, I think.
Exactly. So this is like different parts of the setup you can identify very well, and exactly how you said it. You have some extension wires. The brown wires are taken here as like an extension, and the transmission coil itself is the black material there, the black insulation, which is also just installed with zip ties to the parts of a car, and that's it. The system, due to the mechanics behind in the system, it always sees the exact resonance point, how it's working perfectly in these circumstances, and it's adapting to these installations automatically. Really
cool. So, okay, next picture, something very special, as it seems.
Yeah, that's a gearbox output of a sports car. The telemetry is installed on just a 20 millimeters flange, and it's a mechanical, very rugged installation. With this installation, we measure peak values of up to 10,000 Newton meters at this point, and this requires very little installation space at the same time. So even if maybe a drive shaft is snipping at very, very high torque, this stable flange will remain without any damages, and can go ahead and measure.
Okay, so you explained it to me. I try to explain it to our viewers. This red ring here is the rotor unit, the antenna of the rotor unit, I think.
Yeah.
And I think that the strain gauges are laminated in here inside in this black ring, and we see here the small where the cables are going out to the antenna, I think. Am I right?
Exactly.
And here we have the antenna of the stator unit then, and here the stator unit
exactly.
itself.
So the red ring is the rotor antenna and the rotor unit, both at the same place. And then on the inside you have the strain gauges.
Yeah, and it only takes up like 20 millimeters here. That's really, really cool. Okay. So, and of course, our telemetry systems do not live in the clean laboratory, but they are used in very rough environment, as it seems.
Exactly. So we of course not only provide the telemetry systems, we can help our customers and with drive shaft installations or measurement shaft installations. And if we do this, we cover it with this kind of technology with different layers of silicons and at the end with some glass fiber epoxy, very special and very robust. And with this kind of installation, the shafts are really working for years, even if they're under salt water conditions and oil conditions.
Okay, good that you mentioned years, because as we can see here, we have a picture of telemetry installation which worked quite a long time in the test car, right?
Yeah. So we really know how hard and demanding testing can be, and this is a nice picture because the shafts just came back for recalibration. They missed not one measurement sample. Everything is in the box. The measurement was performed perfectly, and these shafts are still working perfectly. They're just here for recalibration and some rework and back to the car. And that's exactly how our systems are designed for this harsh environment.
Really cool. So another picture of harsh environment, as we can, yeah, it seems that there's a telemetry system beyond all this dirt and mud there. So this is quite a robust system, this picture is telling. Okay. Yeah. So Gerhard, as a customer, can I install all of this telemetry system and fit it and install it myself, or can I get some help from AXON if I'm not the pro that I should be for telemetry systems?
You can, at AXON, you can have the full spectrum. So you can just order your own telemetry system. It comes with a manual. You have access to our support. Our support is free of charge. If you're going to install a system by yourself, we can help you even by a step-by-step introduction and manual for your individual measurement task. You can do it by yourself without any problems. It's very easy. The manual is very detailed, so you can do this. If you don't want to do it, if you need help, we are here. We're doing the right on your place, your service, and help you. And also we do the shaft installations, calibration service here in-house. This is another big part of AXON Systems. We have very short delivery times. You can get your individual measurement shaft within usually 10 working days. So this is really, really fast. And we have all the service here. So we have the hardware, we have the installation service, we have calibration. So it's like a key-ready solution for you if you want to go with those systems and measure on rotating parts.
Okay, sounds really great. So now we took two another examples of very special things you develop for your customers. And one of these things is the fly disc. I think it's done for if we have very, very little space between the engine and the gearbox, right?
Yes. So initially it was designed to fit the complete measurement system between an engine and the gearbox. Mm-hmm. And now it comes into action if only a small gap is available in where to make the complete transmission of the signals. Mm-hmm. So if you see there, the blue part is the rotating part. This is the fly disc itself. It contains all the electronics. It contains the rotor antenna and everything. You just connect your strain gauge. In that case, the strain gauge from the engine was connected. Mm-hmm. So this is the blue part. And if you have a closer look at the black part beneath, this is really very thin laminated stator antenna. It's about just a millimeter. It's right on the aluminum housing of this engine, and it's still transmitting inductive energy enough for the system to work.
Yeah, really cool. So great to see what is all possible with AXON and the telemetry systems you designed. And here's another example of this time temperature measurement. I think at brakes.
Exactly. This is a customized temperature measuring device as a turnkey solution for a large railroad test bench here in Munich. And it's a multi-part ring, so you can disassemble it and mount it on an axle of this test bench. And on this Lemo connectors, it's very easy just to connect the thermocouples. Mm-hmm. And then you have a complete wireless and maintenance-free telemetry system for temperature measurements. Working for a couple of years now, very successful here in Munich.
Perfect. Okay. So, Gerhard, we have also been active in the field of electric mobility for several years now. And at CSM, for example, we have developed a whole bunch of devices for high voltage acquirement of all possible measured variables. So what are, from your point of view, in terms of telemetry, the typical challenges if it comes to e-mobility?
So if you have an e-drive, you might have already experienced the main issues of e-drive automotive systems, that you have interferences, especially if you're going to measure small, tiny signals and sensitive signals. So this is the same issues we have. So we found solutions on the rotor unit side to make sure that we have a safe acquiring of the analog signals. But on the other hand, we have an additional problem that we also have to transmit the data wirelessly within this EMC loaded area and make sure that the data arrives and the data is uninterrupted. And so we found some quite nice solutions for this.
Yeah, and I love that very much. So keep on talking.
So these inverters of the car are really interfering with the data stream of a standard telemetry system, and you can see it on the scope here how this might look. If you accelerate your car, you can get all these peaks and spikes in your signal. And so we developed anti-EMC, and this is not just a filter. Anti-EMC it captures the surrounding electromagnetic noise with a separate antenna.
Yes, sir.
Exactly. And then we have a little bit more information which we can work with. So on the one hand, we have a receiving antenna, which receives our usable signal and also receives the interfering signal and mix it up to something which we even cannot understand on the receiving part. But on the other hand, we have just a receiving antenna just for the surrounding, for the interferences from the surrounding. And then we have the two informations. We have the mixed signal on the one hand, and we have only the interfering signal on the other hand. And then we can start to calculate and try to recover the original data stream. And this is maybe something you can compare with on the acoustic side with those noise cancelling earphones. They're working quite the same. Yeah. So they have also they record the surrounding and subtract the surrounding from your mixed signal. And this is what we do, but not on acoustic. We do this on electromagnetic field. And we developed this together with some large OEMs when they started to test their own electric cars. And this is a really successful result of this research, our EMC noise cancelling system.
Yeah, that's really, really good. And I think this is really a feature that makes AXON telemetry really future-proof, because obviously the future will be electric. So we will have a lot of EMC maybe in the next few years in our cars. And I think EMC noise cancelling from AXON fits perfect to that demand to measure with telemetry. Really cool. So one last question, Gerhard. Somehow your systems have to be integrated into the, for example, vector CSM infrastructure. So how do we do that?
As explained before, we have two output variants on each control unit. You can come with an analog output. So if you have somewhere a plus minus 10 volt input of your measurement device, you can use this. But much more easier, of course, we have the CAN bus output. We have a tiny little software tool where you can create your DPC file. You just can include this into your measurement setup in your measurement CAN bus, and then there you go. Then you have your AXON rotating measurement data inside your CAN bus of all the other measurement points. And here we go.
Okay. Perfect. So, dear viewers, if you have any telemetry applications that you're looking for, truly innovative telemetry specialist who, in addition to their products, also offers you the all-round carefree package for the instrumentation of your test specimens, then you are also welcome to us, to CSM, because we at CSM are also distribution partner for AXON Systems, and simply contact your sales representative at CSM, or if you do not have yet one, simply write to sales@csm.de. Gerhard, thank you very much for being here. It's very great that we have you here with us today. And I think for whole CSM, I speak for whole CSM when I say thank you for being our partner in telemetry for so many years, Gerhard.
Thank you, and it was really a pleasure.